Hello everyone, today we are doing two vectors, vector D and vector E. This is vector Dora and vector Evan. And you're trying to find out how you can get cross products from magnitude and direction. So I know the magnitude of both of my vectors are going to be 10 and 15, which means vector D, whatever they're going to have, they might have something less than or being smaller than vector E. But that doesn't really give us what we want for cross product, which means the components. So what I'm going to do is I'm going to go ahead and do the Cartesian coordinate system, y hat, x hat, and z hat, and from that direction I'm going to find out what is the components of each of my vectors. Now I have been given the angle for those angles, but the problem is I don't usually use dot product for this problem, so I'm not going to even use those. So I'm going to go ahead and use an x and a y hat. So it seems that my y hat, it seems to be in the same level as what vector d's y is going to go. So I'm gonna say, okay, vector D, vector Dora's y hat is going to be plus 1 hat, because in the same level with my y hat. And then I'm going to use and see that, okay, my x hat does not match what vector D wants, vector Dora wants, so I'm going to go 3 towards the right until I get level with vector D. So I find out that my x hat for vector Dora is going to be 3x hat. For vector Evan, we're going to do the same thing, but we find out, okay, my y hat also is not on the same level, so I'm going to draw another y hat and find out my y component for vector E is going to be 1.5 y hat. That's going to be positive because we're going up. Now for x component, we're going right to get positive, but vector Evan is going left, so we're going to go negative 1x hat, negative 2x hat, negative 3x hat, and get negative 3x hat for the x component. Now we're going to use these two to determine the cross product, because we're getting a vector from cross product. So I'm going to use 3x, I'm going to cross it with 1.5 y hat, and since I'm going x to y, I'm going to get positive because I'm going into the circle, so I'm going to get 4.5 z hat. Now the other way is now I have to use 1 y hat and cross a negative 3x hat. So I'm going from y to x, so I'm going to get negative because I'm going against the circle. So I'm going to negative 3 z hat. Now that I'm doing that, I'm going to get 4.5 z hat minus 3 z hat, gain 1.5 z hat for my vector, which I'm going to call vector Mike. It's going to be vector at. That I'm going to get 1.5 z hat. So that's how I'm going to get one of those ways that I want to get. But the thing is, this question also wants us to find out vector Evan cross vector Dora. But the problem is I don't have any space now, so I'm going to use that in my new space. Cross product of vector E and vector Evan and vector Dora, because we already done that on the other one, vector Dora and vector Evan. Now we're going to have us the cross product, so we're going to do the same cross thing. And the thing is, we're just going to have difference because we're going to be in the opposite direction and get 3 z hat negative minus 4.5 z hat, and negative 1.5 z hat is going to give us the vector next step. So hopefully you guys learn about this and you see, because we use the right hand rule, we use a lot of stuff. We know that's going to be perpendicular, it's going to be 0. And because it's going to have z hat, it's going to come out of the board. It's going to be cross product perpendicular. And we are using the z hat, we're using our components to get to the cross product. And we use them, the right hand rule, the Cartesian coordinate system, x hat, y hat, z hat, to get the components of our vector. So hopefully you guys learned something new, and let me know in the comments.